All right, guys, today we are on the third section of Chapter 3, Solve Multivariable Linear Systems, commonly known, 3 equations, 3 variables. So don't let that scare you. It just means we are using more elimination. Instead of just 1 round of elimination, some of these can take up to 3 rounds. But let's just wait for that. Let's start off with something easy. Solve the following system of the linear equations using back substitution. So super nice. They are giving you one of the answers. You know z is 2. So you are going to work your way backwards through the system. Go to your middle equation, and now we're going to replace the z with 2. 3 times 2, of course, 6. And we're going to subtract 6 off of each side. Y, negative 1. Now we're going to go back to the beginning equation. You're working backwards. I'm going to rewrite it down here at the bottom so I have room to work. X minus 2 times y. Y we got negative 1. Z they told me was 2. And now we can go through and solve for x. Negative 2, negative 1, let's make that plus 2. 3 times 2, 6. And let's just do it mental math. With x plus 8, well, x is going to have to be 1. Now, I'm still going to write my final answer as an ordered pair. Of course, alphabetical order. X, Y, Z. Just to make it look nice and pretty. All right, you're up. Try this one. Use back substitution to solve it. You can see again, they gave you Z. Should be able to do Y probably in your head if I had to guess. Take a second, figure out what Y is. Clearly Y is going to have to be 0. Okay, now you are back substituting into that first equation. Again, I'm going to write it down here so you have room to work. Y is 0, Z is 2. Take a second, figure out what X is. All right, you should come up with X equals 8. Because we're going to have minus 6 here, which we're going to add over 10 plus 6, 16. X equals 8. So final answer, ordered pair style. X, Y, Z. Those aren't so bad. So that's the first couple problems on your homework. Now, let's get into the good stuff. Clearly, I didn't give you any of the answers here. So here's where we're going to have to use multiple rounds of elimination. I cannot stress to you the importance of keeping your work organized, neat, etc. I know how many times I look through these, kids ask me to check them, they miswrote the original problem, or their Z looks like a 2, or something weird like that happens. So try to really be organized and conscientious. I always label my equations just so you know which ones I'm working on, just to be obvious. So I see the middle equation does not have a Z in it. So we could make our lives a little less work if we take Z out of the first and the third equations. I know it might be easier to eliminate the X's. I mean, X and negative X would be super easy to get rid of, but I think it will be a little time saving since the second equation is missing Z. Let's take Z out of the first and the third. So the first and the third, they have a 3Z and a 5Z. Clearly we want to make them 15. So the top one I'm going to multiply by 5. So I'm just going to write a 5 here so you know what I'm doing. Everything by 5. 5 times 2, 5 times 3, 5 times 9. Then I'm going to, of course, multiply the bottom one by negative 3 because I want that 5Z to be a negative 15Z. So negative 3 times 2x, negative 3 times negative 5, negative 3 times positive 5, that's what I'm looking for, and negative 3 times 17, which is negative 51. All right, let's add these together. 5 plus negative 6, negative x, 5y, z is eliminated, 45 minus 51. So now what I'm going to do, we haven't done anything whatsoever with that second equation. So I'm going to write that down over here on the side. Now, some of you, of course, are good enough. You can just go ahead and keep working on it. I'm going to take our answer from my red system of equation, and I'm going to stack it underneath. And now you're down to 2 equations, 2 variables. Well, clearly, this would be a nice, easy system to get rid of x's if we just multiply that red equation by a negative, aka switch the signs. I'm just going to switch them so we don't have to rewrite it. And now let's add these together. X's are gone. 3y minus 5y. Negative 4 plus 6. Remember, I changed that to a plus. Negative 4 plus 6. So y is negative 1. Got it. Now you just, quote unquote, back substitute. You work your way back through the system to find the other answers, just like we did in those first two problems. I'm going to come over here to the left to the red equations, and I'm going to replace this y with a -1. I just chose that because I have room to write under it. 5 times -1, -5. I'm going to add 5 over, so x is 1. And I'm just going to circle my answers for right now so I don't lose them here through all this fun-filled work. Now I need to, of course, figure out z. So I'm going to pick an equation with z. I'm going to go up to the top to the very original first equation, but I'm going to replace x with 1. I'm going to replace the y with -1, and we're going to figure out what the z is. Okay, so -2, -1, let's make that a +2. I'm going to subtract 1 plus 2 is 3, so I'm going to subtract 3 off, so z is 2. And then I'm just going to write my final answer, of course, ordered pair style, alphabetical order, x, y, z. Got it. Now, are there other ways to do this problem? Yes, you could have gone through and eliminated x, or you could have gone through and eliminated the y's. It doesn't matter. But if you see you're missing one of the variables in an equation, it will be less work to work on that one. Now, next problem, you've got everything. We have all the y's, all the x's, all the y's, all the z's. So let's first decide, scan through them, which looks like the easiest variable to eliminate. X's, 1x, 2x, 1x. The y's, -3, -1, 2. I mean, those won't be bad. Neither will the z's. Kind of my rule of thumb is I try to use the smallest numbers just to try to make my life easy. So I think the x has the smallest coefficient, so let's eliminate x. Doesn't matter which two equations you eliminate x out of. Pick two, get x gone. I'm going to start with the first equation. Let me jot that down. And then I'm going to pair it up with the third one. I'm just going to run a -1 through the third one so I can change all the signs. Let's add these together. My x's are gone. Kind of sounds like a bad country song. Okay, got it. Now, I haven't done a single thing with equation 2. We have to get equation 2 involved here, so I'm going to jot that one down. And now I want to eliminate x out of this. It doesn't matter if you pair up 1 or 3 with it. Doesn't make a difference whatsoever. I'm going to do 1, and I'm going to have to multiply it by -2. So -2 times x, or my x's will cancel. -2 times -3y. -2 times z, -2 times 1. Okay, add those up. So I'm going to have 5y minus 4z equals 0. Now what I'm going to do is I'm going to take my answers, my red answer and my green answer, and we're going to put those together. So I'm going to jot this down over here so I have some room to work on it. I know some of you can just combine it. I'm just trying to make it look super pretty for your notes here. And I'm going to stack this one underneath it. Okay, let's add these together. So this is what I mean by 3 rounds of elimination. The first red set, the right green set, and now I have to combo those answers together. But the y's eliminate, the z's eliminate. 2 plus 0, 2. Well, 0 can never equal 2. We know that's a big fat lie. Here we have no solution. All of that work for no solution. Doesn't that make you feel good? But again, that's the setup, 3 different rounds of elimination. All right, let's do a couple more to practice, of course. So again, I always label them. I see we're missing x out of the second, z out of the third. So since we're missing x out of the second, I'm going to work on x's. Plus, I like that x and negative x. I think are going to be super easy to cancel them out. So I'm going to pair the top equation with the bottom equation. Okay, so let's add those together. X minus x, 0. 1y, 2y, 3y. -1 plus 1, 0. Now, because you are eliminating or you're missing the x out of the second equation, I can take that second equation and just stack it with my red answer because we just have a system with y and z in it. Now I'm looking at these two equations and I'm like, wait a minute, they're pretty much the same. The green one, of course, is 3 times the bottom one. So we know by now that that's the same equation. It's going to be infinitely many. But if you actually want to see the work, of course, you could times this guy by -3. And do the work over here quick just to show you. Copy down that red equation underneath it. And you can see we get the 0 equals 0. And we talked about this in the previous lesson. If you can see it's the same equation, just a multiple of each other, like 2/4, 1/2, same thing, multiple by 2, you can, of course, just go to infinitely many solutions. But, as always, when you have your 3 equations, 3 variables, here's the deal. There are an infinite amount of solutions, so we want to come up with a formula, so to speak, that generates all of the different answers. So, how do we do this? Well, you can see I started to write some work there in black. Always start with z. Your first step, we're going to use a totally different variable, so everybody's on the same page. We always start by replacing z with the letter a, the variable a. So this is step 1. Now, just like if you had a number there, you would quote-unquote back substitute. So I'm going to go up to one of the other equations. I'm going to use this red one right above me, because I have room to write, and I'm going to replace the z with an a. I'm going to solve for y. And then with the 3's, we divide them off, they cancel. So y would be the same thing. Now I'm going to go back to an equation that has x in it. I'm going to do the very top one, the very first equation. Y we're going to replace with a, z also with a. I promise this will make more sense in a minute. 1a minus 3a negative 2a. And then I'm going to solve for x, I'm going to add the 2a over. So what I have written in ordered pair style in black, I'm going to circle as my answer. Now, what is important about this? This pattern generates all the answers. Pick a number for a. Let's say I pick 7. So I'd have 7 for z, 7 for y, 2 times 7 minus 1, 13 for x. Pick a different number. 2 for a. 2, 2, 2 times 2 minus 1. Those numbers would work. 100 for a. 100, 100, 2 times 100 minus 1. Those numbers would work. So it's giving you the pattern to generate all of the solutions. So that is the new part here to this lesson. Let's practice that again. Now, I know, you might be like, she lied to us. She said 3 equations, 3 variables. Here we have a system, 2 equations, 2 variables. Well, right away, when you have this happen, it's infinitely many. Whenever you have fewer equations than variables, it's automatically going to kick into that infinitely many solutions. So I know I'm going to have to do that crazy z is a deal. Now, let's take a look at the system. Since we're using z as a, we do not want to eliminate z. I know you're like, let's just add and get rid of z. No, you want to keep z in there. So we're going to eliminate either x or y. Oh, let's do x. Why not? So I'm going to multiply the top equation by -2. 2 times z, and don't forget the 2 at the end. And then I can just stack the second equation underneath. X's are gone. -2z minus z, -3z. And if you want, you can reduce these. They're all divisible by 3. I'm going to reduce them, just easier, less opportunity to make an error. Okay, so now we're going to quote-unquote back substitute. I'm going to replace the z with a. So I'm going to add a over, so y, of course, a minus 1. I'm going to replace that. Now I'm going to go to one of the equations with x. I'm going to do the top one, because we need the answer for x. We'll replace y with a minus 1. We're replacing z with a. And then I'm just going to do my algebra, distribute, and solve. Okay, so the 2's on either side would cancel out. -2a plus a negative a. And I'm going to add a over. Got it. So this, of course, gives you the pattern to generate all of your infinitely many answers. So if you pick a number, any number for a, let's say 10. So I'd have 10, 9, 10. Those would work. 7, 6, 7. 500. 499. Gotta take one off. 500. I mean, I could do this all day long. That's going to generate the answers that would work in all the equations. Okay, you are up. Here is a system for you to try. Scan through, decide if it looks easiest to get rid of the x's, the y's, or the z's. My advice, I'm going to give you a minute to try these, well, maybe more than a minute, but my advice, I would probably do x's. X or z probably comparable. But let's just to be consistent and we're all on the same page, let's eliminate x. So first things first, pick whatever two equations you want to get x out of. I'm going to do the bottom two, 2 and 3. So if I'm going to do 2 and 3, I'm going to have to multiply this guy by a -2. I'm going to give you a minute to set that up and get the x out of it. I'm going to kind of coach you through this last one. So I'm just going to try to catch up. All right, let's add these together. -6 + 8, 2. Okay, you have to work with the equation you haven't done anything with, so we have to work with 1. So I'm going to copy that down. So are you. Now, if we took x out of our first round of elimination, I need you to take x out of this round. So make a smart choice. Clearly, I would want to pair up the second equation with it, but you're going to have to multiply it by -3. So let me give you a minute to do that and add those together. All right, hopefully we got those the same. Now you're going to take your two answers and combo those together. Meaning we're going to take our red one and we're going to put it together with this green one. But I can see we could get the y's or the z's easily enough to eliminate. I just need to do a sign change. So I'm going to take this red equation and I'm going to change all the signs. So I'm going to make it +5y, -10z, -2. And then I'm going to stack the green one underneath it. All right, let's add them up. Of course, our y's are gone, the z's are gone, and we equal -10. Well, 0 can't equal -10. We all know that. No solution. Got it. So easy, yes, time consuming, I would say, is more the issue. Write neat, be conscientious of your calculations. All right, have a great day. Good luck with that.